My name is Pat Grady. I'm a solution engineer at AdSwerve, and I'll be walking you through the foundations of digital marketing. Let's go ahead and get started. Welcome to part 2 of episode 2 in my series on advanced digital marketing. In this episode, we've been looking at embeddings and semantic search. And now in part 2, we're actually going to be hands on keyboard, running some code and using an actual managed semantic search appliance by Google Cloud. And then the open source code that we're going to be running will be a code that was provided to us by Cohere. Highly recommend using their technology to learn and grow into the space when you want to do custom development, and then using the Google Cloud platform if you want to do this managed implementation. So basic semantic search, what are we doing? We're taking a query, something like where is Big Ben? We're embedding that or encoding that information into a vector space. That's a query embedding. So we turn that text into numbers. And then we're cross-referencing that vector embedding against a corpus of text that has also been converted into embeddings. And the reason why we do this is that you not only get a text-based search, where is Big Ben would only give us responses that had these words, where is Big Ben, or any subset of these words. In the query embedding space, you can actually start to get semantically similar concepts that don't actually include the same words. That's one advantage. The second advantage is just speed and performance. Analyzing numbers in a highly dimensional space against analyzing and parsing text is incredibly operationally efficient. CPUs, GPUs like numbers. This is a search technology completely based on numbers. It doesn't care about the text until the very end when it reinterprets the numerical representations back into the actual text representations of the data. So this is why Google uses this technology. This is why Stack Overflow uses it, because this kind of thing can also come out with things like people also liked, people also asked this question. So you can kind of find things that are very similar to this. So let's go ahead and take a look. We're going to be installing some software. I already did it. It takes a little bit of time to do this, but we're installing Cohere, the UMAP to do the dimensional reduction. Altair is just for visualization. Annoy is the approximate nearest neighbors. Datasets is just a corpus of data. And TQDDM is just a nice little tool used to visualize when something is taking otherwise a long time or you're looping through something. So you do not need to know code. In fact, this whole series is about gaining technical fluency. It is not teaching you about how to code. It is teaching you just to understand the concepts and what your data science teams, your IT teams, your technology teams are up against so that you can have effective conversations with them when you're wanting to accomplish certain goals. Like, for example, offer your customers a better search experience and surface the content and the products that are relevant to them using this new technology, or not new technology, but using this sort of advanced search appliance technology. So I'm getting set up. We're going to import some libraries. I have a model key. If you follow along, I'll try to provide some links in both the video description and in the corresponding blog article, but you'll sign up for Cohere, get your API key, and then you can follow along very precisely. This notebook that I'm running is also open source and very easily available, and I'll provide some links to that. So you can run this yourself and tweak it yourself, just like I did. So let's get started. Let's download the data set, and let's actually take a look at some of the data within that corpus. We have 2,000 rows of data. We're only looking at the first 10. And there's just all these kind of random questions throughout this data set, and they have all of these different labels. Don't worry about the labels now. We'll analyze those labels later. But it's things like, is this a person? Is this abbreviation? Is this referring to these different concepts? Lots and lots of questions. So in this particular example, we're going to be embedding the query using a technology called Embed v3. There's lots of open source technologies that can, given text, can embed text, but this is just the one that we're using. It's open source and had this great documentation to go along with it, including interactive code examples. So what we're going to be doing first is creating the text archive and then using a model to encode that archive into a series of embeddings. So we're going to take that list of questions and we're going to use this library to create the vector embeddings. So here we have an array of 2,000 sentences and correspondingly vectors that are 1,024 numbers long. So these little 3 squares are actually 1,024 squares that represents the embedding space. So we're going to create the index, and now we have 2,000 text questions that have been embedded and now will be saved as an index called test-anon. And so that's exactly what we're going to do. So we're going to just demonstrate the first query. So we'll take that random sentence, which is how many people in the world speak French? And then we're going to look at the approximate nearest neighbors of all the other sentences, of all the other 2,000 sentences that were in the corpus, and find the ones that were the shortest distance between the closest neighbors, the nearest neighbors to that question. So when I ask a question like how many people in the world speak French, it decided, or it found, that out of the corpus of 2,000 questions, it said how many different languages are spoken in Europe. What is the goat population of the world? What is the most commonly spoken language in Belgium? So I think that what is the French flag? It's definitely sort of on topic. Now, we only gave it 2,000 examples. The more examples that I give it, 5,000, 10,000, 86,000, it's going to do better and better and better about finding sentences that are tightly aligned or similar to the original query. But these out of the corpus, these are the closest approximation to use. So let's find some nearest neighbors. We're going to not just limit ourselves to the actual corpus. We can input new completely random questions that were not in the data set. So I just came up with a question, what are some interesting facts about Canada? And sure enough, it comes up with questions that are fairly close by that are like, what are some interesting facts about dog sledding? What's the official animal of Canada? How many Canadians emigrate each year? So I think that those are definitely questions that are very, very similar to my input, and they're related in some way. In fact, almost all of these are going to be related. Maybe there were some significant historical events from Canada in the 1990s. I don't know enough about Canadian history to know either way, but that's the situation. So now we're going to go ahead and plot the archive. So one of the things that we've done is in our corpus, we did have labels. So now this is where we're actually going to look at those labels. And we're going to look at the similarities from those 2,000 elements that we process, and to see if the vector embedding space, when we compress those vectors into just 2 dimensions, what we actually see in terms of the classification. So each question had this high level classification, like, is it an abbreviation? Is it a concept? Are there entities defined in it? Is it about humans? Is it a specific location? Is it about numbers? And so we could see that there are some tightly coupled questions, like the class location seems to pretty much be densely populated near each other. So what are the 5 most expensive cities in the world? What Caribbean island sometimes is called Little England? Those are the types of questions that have been determined to be extremely close to each other in the dimensional vector space. Also, it looks like numeric. So anything about, where the question is resulting in a numerical response, then how many colored squares are there in a Rubik's Cube? Those types of ideas. There's a number response. It's very, very clear. The ones that are less clear appear to be the entities. They're sort of spread out. There's definitely some overlap. Humans, who replies, I know, to Princess Leia's confession, I love you, is very close to when was Yemen reunified. Not sure why. It's just that's the numerical representations of those are very similar to each other. And so these would probably be fairly bad answers in our search appliance. Whereas if we were asking questions about numbers or locations and potentially about entities, what are bellworths, what's a nanometer, those types of things seem to be very similarly adapted. So definitely given a corpus that's extremely random, and we're only looking at a very small subset of the total corpus just so that we can fit it into this in constraints of the visualization. So that was fun. Now let's actually go into another application. Now I want to just build a search appliance for my website that takes advantage of all this technology, and I don't want to know anything about how to do it. So here's what we're going to do to accomplish that. We're going to take 79 PDFs that I've grabbed off my website, the public facing version of the website, through old blog articles and case studies and all these types of things. So these are just 79 PDFs that are out there. You might have a similar data set, or files or documents for internal purposes or external purposes, or maybe you have a website that you can crawl and those types of ideas. So that's the data that I have available. And what I would typically have to do if I wanted to build a search appliance is I would have to go and build an archive of embeddings for all those documents and then be able to cross-reference search queries with that. But they're PDFs. How do I convert a PDF to text? I'd have to implement a PDF parser and all these things. So there's a lot of work that needs to be done to be able to make this work. But we're just going to make it work out of the gate. So I downloaded the files and I literally just dragged and dropped them into this interface. Now I'm going to go over to my handy dandy search tool and search for something called Search and Conversation. And within Search and Conversation, within the Google Cloud Platform, I'm going to create a new app. And the app that I'm going to build first is going to be a search appliance. And so I'm going to click Search. I'm going to check all the features. There's reasons why you would choose one over the other. I'm going to just show you the most advanced, awesome version. And then you can decide yourself to know which version that you're going to use. And this is my demo search appliance. and the company name is called Answerve, and the region that I'm going to want to operate in is we operate in the United States. So let's go ahead and continue. Okay, it's configured and now it just needs data. So let's create a new data source. You can do something like crawl your website and turn your website into a vector embedding space. You can query tables of data from BigQuery. You can point it to a cloud storage bucket that has all your documents, which is what I did. So process and enrich your PDFs with OCR, sure, advanced table parsing, and use native text. So sure, just like do all the things for unstructured documents, which unstructured documents can include PDFs, HTML, text, CSVs, for FAQs. They can also work with PowerPoints and Word docs and those types of things. Okay, we're going to go ahead and get that running. Whoops, I need to actually point it to a folder called Marketing Demo Search and Conversation. So this is the folder. Yes, absolutely. So I'm just going to select the folder that has all of my files in it, and then I'm going to continue on. My data store name is just the Answerve PDFs. And whoops, PDFs. That's what it is. It doesn't really matter what you name things, but you should name them in something that other people can understand and interpret. So we're going to go ahead and select this as the data source that we want for our new application and hit create. Now what's going to happen is the tool is going to start processing the data. It's going to scan through those 79 PDFs that I've uploaded. It's going to OCR them. It's going to analyze the text. It's going to turn everything into a vector space and then create a search appliance on top of that. So I'm going to go ahead and press pause on the video, and then we'll resume once this activity is complete. Okay, here we are, and now we see that the documents have loaded and basically all the PDFs have been scanned. They've been vectorized, if you will, and so now it's time to actually go back and test the application. So when we jump back into the application itself, we can see that we're given a prompt. The way that you would integrate this prompt into your website experience you would get from the integration code. So you would just take this sort of JavaScript code, you would sort of configure it to be either authentication based or public access, and then you of course restrict it with a particular domain to make sure that no other domain can steal your search appliance. And then this code, when you integrate it into your website, would actually display in this way. It would present itself wherever you put that little Gen app modal into this type of experience with a little search bar. So let's go ahead and just get started. So I'll just run a search for BigQuery, and then it will actually generate a sort of answer. I say run a search for BigQuery, it actually gives an answer that's configurable. So we can have search with answer, we can have just regular old search. So if I can run the same search and just using the regular search appliance, then this is what shows up. Answerve's BigQuery offering. Let's check it out. Is it relevant? Of course it is. It is relevant because it talks about BigQuery throughout the whole thing, and they reference lots of different case studies in which we talk about BigQuery and all the benefits and why it's important and all those sort of concepts. So certainly relevant results that it was able to parse through just analyzing PDFs. And like I said, there's website crawlers and lots of different ways that we can do that. We showed the search with answers, and then finally there's the search with follow-ups. So like BigQuery, and it generates the same kind of answer. Note that these are also cited references. So when it says BigQuery is an enterprise data warehouse, then it's actually making a reference to this document. That's pretty powerful in making sure that your search recommendations or your answers are grounded in truth and grounded using your own documentation, your own website, your own FAQs, those kind of concepts. And so that it's really restricted from hallucinating out of the gate by the design of this particular managed search supply application. So where do I get started? And so the question here would be, does it know that I'm asking where do I get started with BigQuery? So yes, it does. You can use a vendor like Answerve, Fivetran, Stitch Data to move your data into BigQuery. So absolutely, the follow-up questions, where do I get started, have the full context of what led to that particular experience. So certainly powerful capability, and is something that at your fingertips, we're able to deploy using that integration code, get that into a production website with relatively little effort, and have the full power and expertise of Google's search logic. Other ways of doing it, which is building your own semantic search appliances, building your own indexes, running your own sort of retrieval services, and augmenting the results. So lots of different ways to go about these problems. Definitely recommend checking out these tools. I'm going to go ahead and made a chat agent, and let's just see if it actually is up and running. It might not be It might still be scanning. Yeah, it looks like it's still potentially scanning. Oh, no, it looks like it has all the data available. So this would just be an example of a chat agent. We can go ahead and test the agent out. Right out of the gate, we would be able to do things like, what services does AdSwerve offer around BigQuery? And of course, AdSwerve sells other services than just BigQuery. This is just something that I think you would frequently comes up. So we offer a premium data transfer service for BigQuery. The service includes a $500 monthly allowance, all these kind of concepts. So it's definitely, it's citing that information. It's making sure that it references exactly what it's talking about. What else does AdSwerve do? You know, you can actually route people to specific forms or actions on the site using API integrations, using lots of different customization. This is literally just the very starting point of what you can do with these types of chat products using super powerful technologies like Dialogflow CX. With that said, we're going to go ahead and end this particular demonstration, and we look forward to you staying tuned for the next episode in this series, and we'll see you then.